In this video, we are going to look at two special cases when it comes to factoring. Our first special case is called difference of squares. There's a few characteristics that are going to help you be able to identify when you have a difference of squares. The first thing you're always going to notice is that it's always going to have two terms. So when you're asked to factor something with two terms, you might be thinking maybe this is a special one. The other thing that you should notice is that it's always going to be a subtraction. So two terms with subtraction. And then the other thing is that both of the terms are going to be perfect squares. Numbers that you could do the square root of. So if those three things are true, then you probably have a difference of squares case. And this is the factored form for your difference of squares. Now we're going to look at this in an example here in a little bit, but just to get this down in your notes first, we want to make sure that we have this formula that we're going to be using to factor. The other special cases that you might see are difference and sums of cubes. So in this case, you should also be looking for two terms. But in this one, you can have addition or subtraction. So we've got a formula here that will help us if it's subtraction, and this one here that will help us factor if it's addition. And this one is going to be things that are perfect cubes, or things that you could do the cubed root of. So we're looking for cubed things. And if you need that list, remember you can create that list that looks like this to help you find all of those cubic things that might help you when you're doing your homework. So like 1 cubed is 1, 2 cubed is 8, because 2 times 2 times 2 is 8. And you could create this list if you wanted to on a test or quiz to kind of help you out. 3 times 3 times 3 is 27, and so on. Now I know these formulas are pretty intense looking up here. There's a lot going on, but you'll also notice that there's a lot that's the same. These guys kind of match, only their signs are different. And this matches this, only their signs are different. So one way to think about these signs and to remember these signs is an acronym called SOAP. SOAP stands for same, opposite, always positive. Same, opposite, always positive. So what that means, if you think about it up here, if this is a minus, this sign is going to be the same, this one's going to be the opposite, and this one's always positive. For an add, this one's the same as this, so add, opposite, always positive. Once you have the signs down, the number, or the A's and the B's all match. Let's look at an example. So I'm noticing right away I have two terms. So I'm guessing this is going to be one of the special cases. Now I have to decide, is it a difference of squares or is it cubic things? So first key that I'm seeing is right here. I've got an x squared. That's a big hint. We're probably dealing with squares. But also think about perfect squares. 9 is on that list of perfect square numbers, and so is 49. So I think that I have difference of squares here. And it's a minus, so we're in good shape there. So I want to decide what's A and what's B. That's going to help me factor this. A is what when you square it would get me back to 9x squared. So what when I square it is 9x squared. Well, 3 times 3, or 3 squared, is 9, and x times x would give me x squared. The b value is what when you square it gives you 49, so that one is going to be 7. Now if you look back at the formula for factoring difference of squares, now that I know my a and my b, I can just throw them in that formula. The formula says a minus b and a plus b. So I'm going to do a minus b. So my a is 3x minus my b, which is 7. And then I'm going to do my a plus my b. This is the factored form for this binomial that we started with. If you were to FOIL this, you would get back to here. And you could do that if you had extra time on a test and wanted to check it. Remember, one's going to be negative and one's going to be positive, and actually it doesn't matter which one you put first as long as you have one of each. Let's do one last example here. Before we even start, the first rule of factoring forever and always is GCF if you can. And in this case, I have a GCF. So I'm going to pull my GCF out. It's going to be, I think, 3, and they both have an x, so we're going to pull a 3x out. If I pull a 3x out, that's going to leave me with x to the third plus 27. So now I'm looking, and I notice I have two terms, so it's a special case. It's a plus, so it's definitely not difference of squares. That would be a minus. And this x cubed is giving it away. That's probably a cubic thing. So let's start by finding a and b, knowing that we're dealing with a sum of cubes. So looking at that, let's find our a and our b. So let's see here. What when you cube it gives you x cubed? Well, I think that one I got. That's an x. Now, what when you cube it gives you this 27? So you can look back at that list that we created. I think that one's going to be 3, because 3 times 3 times 3 would be 27. Now, don't lose this GCF. He's part of my answer. He's going to hang out. And now we're going to look back at that formula and put the a and the b in the right spot. Now, my a is x, and my b is 3. So this is a plus. And we're going to start with the same plus, so x plus 3, because it starts with a plus b. Now this one's a little bit longer and a little bit trickier. It starts with a squared. My a is x, so I'm going to have my a being squared. Now remember that SOAP acronym? This is the same, and this one is always opposite. So I know this is going to be a minus. And in the formula it says AB. So take your A times your B. So x times 3 is just 3x. And remember that SOAP acronym. Same, opposite, and this one is always positive. And then it says in the formula we need a b squared. My b is 3, so when I square him, I get 9. This is the factored form. If you had time, again, you could multiply these guys, and you would get back to here. And then you could pull the 3x through, and you'd be back to here. This would take a little bit longer to multiply. You're not going to be able to FOIL this. Remember, you have to take x times everybody, and then 3 times everybody. And then a lot of things are going to cancel out, and it would bring you back to here. So remember, anytime you have any factoring problem, the first thing you're always going to look for is GCF. Once you have the GCF pulled out, if we have two terms in here, it's probably going to be a special case, or it may be that you can't do anything. And that's okay too. So you're always going to pull your GCF out, and then if you have two terms, then you've got to decide, is this a square thing or a cube thing? And this x variable, a lot of times, will give it away to you.